welcome you all to my fourth and final lecture on network synthesis. In my previous 3 lectures, we have seen the introduction regarding network synthesis, the in detail procedure of how to synthesize a given RC as well as RL impedance function using 4 canonical forms. In today's lecture, we are going to see the detailed procedure of how to synthesize a given LC impedance function using 4 canonical forms. So let us consider this example. So Z of S is given as 4 into S squared plus 1 into S squared plus 4 divided by S into S squared plus 4. First we should check whether this belongs to an LC function. So the poles, that is the denominator for which the S value becomes 0 are, as we know, S is equal to 0 and S square plus 4, if this should become 0, then S square is equal to minus 4. So S is nothing but plus or minus J2. So these are the 3 values for which your denominator of the expression becomes 0. Similarly, zeros, that is S square plus 1 is equal to 0, so which implies S square is equal to minus 1, so S is equal to plus or minus J1. Similarly, S square plus 9 is equal to 0, which implies S square is equal to minus 9, so S is equal to plus or minus J3. So these are the 4 values for which the numerator of the given expression becomes 0. So if I draw the pole 0 plot, so this is the origin. Let us consider this as J1, J2, J3, and let us consider this minus J1, minus J2 and minus J3. So you can see poles are 0 and plus or minus J2. So plus J2 and minus J2. Zeros are between plus or minus J1. So 1 J1 minus J1 plus J3 and minus J3. So after drawing pole 0 plus, you can see that all the poles and zeros are lying on J omega axis only. So if all the poles and zeros lie on imaginary axis or J omega axis only, then it belongs to an LC function. So let us see now how we can synthesize this given function using the first method, that is Foster first form. So given that Z of S is equal to 4 into S squared plus 1 into S squared plus 9 divided by S into S squared plus 4. So the procedure remains the same. Here you can see the degree of the numerator is 4, whereas the degree of denominator is 3. So the numerator degree is greater than denominator degree. In fact, it should be less than, the degree of numerator should be less than the degree of denominator. So if in such case we consider dividing numerator and divide denominator once. So if I multiply both numerator and denominator, so I will get 4 into S power 4 plus 40 S square plus 36 divided by S cube plus 4S. So when I divide the numerator and denominator once, so S cube plus 4S, this is 4S power 4 plus 40S square plus 36. So here I should get 4S cube. I have 4S to the power of 4. and I have an s cube here. So I should multiply by 4s, which will give me 4s power 4 plus this becomes 16s square. So the remainder is 24s square plus 36. So since the remainder is positive, the given function z of s I can write as 4s plus 24s square plus 36 divided by s cube plus 4s. So this I can write as z of s is equal to 4s plus 24s square plus 36 divided by s into s square plus 4. So the first term is in the form of Ls. So the first term is an inductor. So L1 is equal to 4 henries. So I have to apply partial fractions to this second term. So on applying partial fractions to the second term, that is 24 s square plus 36 divided by s into s square plus 4. So this becomes a by s. Since I have s square plus 4 term, it is nothing but bs plus c divided by s square plus 4. In previous two lectures, we have seen how to find the values of constant by a easy and shortcut way, but that method is not applicable in this case. Remember, if you have any term of the form s square plus a square or of such type in the denominator of the expression, such method will not be valid. So the second way of finding the constant values when you have such term is nothing but finding LCM and comparing the coefficients on both the sides. So this I can, when I take LCM, this becomes s into s square plus 4. This I can write as a into s square plus 4 plus bs plus c into s. So when I compare the terms on either side of the expression, that is nothing but 24 s square plus 36 now is equal to a into s square plus 4 plus bs plus c into s. Now I will compare all the coefficients on either of this side. First, let me compare the coefficient of s square on both sides. Here on left hand side I have 24. On right hand side the coefficient of s square is a plus b. So it is a plus b. So now the coefficient of s on either of the side of the expression. Here there is no coefficient of s, so the value is 0. Right hand side the coefficient of s is c. So directly we have got the value of c, which is equal to 0. And comparing the coefficient of s power 0 on both sides, s power 0 is indicating the constant terms on either of the expressions. Left hand side constant value is 36 and right hand side coefficient is nothing but 4a. So from this the value of a is 9. So if a value is 9, from this expression b value is 15. So we have obtained all the values of the three constants. So the given expression z of s can be written as 4s plus, since a value is 9 by s, anyhow c is 0, so bs plus c. So c anyhow value is 0, so b value is 15, so 15s by s square plus 4. So this I can consider as z1 of s plus z2 of s plus Z3 of S. As we have already seen, this value indicates is in the form of L1S. So L1 value is 4 Henry. The second term is in the form of 1 by C1S, which implies C1 value is 1 by 9 farads. The third term is neither in the form of LS, neither in the form of 1 by CS. So it means this is nothing but the parallel combination of L and C. So let us consider the third term, that is Z3 is equal to it is 15S by S square plus 4. So since we have got a parallel combination, always ensure that the numerator is 1. So this I can write as 1 by 15S into S square plus 4. So this I can write Z3 of S is equal to, so if I multiply, this becomes S by 15, and the second term becomes 4 by 15S. This I can write as Y3 of S. Since admittances are being added, these two are in parallel. Okay. So this is an admittance term, so it is in the form of C2S, so which implies the capacitor value is 1 by 15 farads. So this second term is in the form of 1 by LS, so which implies L2 value is 15 by 4. So we have got all the values. So as we know, the general representation of Foster first form is, since we have only 3 terms, instead of Z1 I have an inductor of 4 Henry. Instead of Z2 I have a capacitor of value 1 by 9 farads, and instead of Z3 I have the parallel combination of inductor and capacitor. And inductor value is 15 by 4 Henries and capacitor value is 1 by 15. So the network obtained after synthesizing this impedance function belonging to LC is, using Foster first form, is 1 by 9 farads. Here inductor and capacitor. Inductor value, as we have seen, 15 by 4 Henries, and capacitor is 1 by 15 farads. So then a second method is Foster second form. So Foster second form, let me write first the expression given. Z of S is equal to 4 into S square plus 1 into S square plus 9 divided by S into S square plus 4. So for Foster second form, we know that we have to consider Y of S, just interchanging numerator and denominator. So we get S into S square plus 4 divided by 4 into S square plus 1 into S square plus 9. Here the degree of numerator is 3, the degree of denominator is 4. So the condition is satisfied, that is the numerator degree is obviously less than the denominator degree. So we will go directly to apply partial fractions. So before applying partial fractions, I'll just rewrite the given expression as y of s is equal to, I'll multiply the numerator s cube plus 4s divided by 4 into s square plus 1 into s square plus 9. This again I can rewrite as s cube plus 4 plus 4s plus 4 divided by s square plus 1 into s square plus 9. So I have taken that to numerator. So again, since here also we have two expressions of that same form, s square plus 1 and s square plus 9. So this, if we apply partial fractions, it becomes as plus b divided by s square plus 1. So cs plus d s square plus 9. So here also the shortcut way of finding the constants is not applicable. So the only way that we can find the constants is by finding LCM and comparing the coefficients on both sides. So here if I take the LCM, it is s square plus 1 into s square plus 9. So as plus b into s square plus 9 plus cs plus d into s square plus. So let us compare the coefficients of both numerator as well as denominator. So keeping this as reference, the numerator is anyhow s cube by 4 plus s. So s cube by 4 plus s is equal to, here we have as plus b into s square plus 9. as plus b s square plus 9 plus cs plus d into s square plus 1. S square plus 1. So here first let us compare s cube coefficients on both sides. So on left hand side it is 1 by 4, on right hand side it is a and c. Next, s square coefficients, if I compare, there is no such coefficient on LHS, that is left hand side. So 0 is equal to s square is b plus d. So if I compare s terms, it is 1 on left hand side, on right hand side it is 9a and c. And lastly, the constant term, there is no constant term on LHS, so 0 is equal to, the constant term here is 9b plus d. So it is very obvious from these two expressions, b plus d is equal to 0, 9b plus d is equal to 0. So even you solve these two expressions, we can clearly see that b is equal to d is equal to 0. So we are left with two expressions. If I solve the first and third expression, we'll get a value as 3 by 32 and c value as 5 by 30. So we have obtained all the values of the constants. So let us rewrite the given expression. y of s is equal to, so it is a value is 33 by 32 into s divided by s square plus 1. B value is 5 by 32, so it is 5 by 32 into s divided by s square plus 9. So this I'll consider as y1 and this I'll consider as y2. So both the terms are neither in the form of CS or 1 by LS. So since both the terms are parallel combination of L and C, let us make both the numerators as 1. So if I consider y1, so y1 we have got as 3 by 32 into s divided by s square plus 1. So if I want to make the numerator as 1, it is nothing but 1 divided by 32 by 3s into s square plus 1. So upon expansion, y1 becomes 1 divided by 32s by 3 plus 32 by 3s. This I can write as 1 by z1s. So since impedance are being added, these two elements should be in series. So since this is an impedance term, this is of the form L1s. So L1 value will be 32 by 3 henries, and this term is in the form of 1 by C1s. So C1 value is 3 by 32 farads. Similarly, Y2, if I consider, it is 5 by 32s divided by s square plus 9. This I can write as 1 divided by 32 by 5s into s square plus 9. So if I multiply, so y2 of s becomes 1 divided by 32s by 5, and this becomes 288 by 5s. Second item is 1 by z2. So here again, since impedances are added, both elements are in series. So this is an impedance term, so it is again in the form of L2s. So L2 value is 32 by 5 Henry. So this is in the form of 1 by C2s. So C2 value is 5 divided by 288 farads. So we have obtained all the elements. So let us draw the network. The general representation of the network of Foster second form, as we know, is y1, y2, y. Instead of y1, if I turn back, instead of y1, so y1 we have written as 1 by z. So z, if impedances are added, both are in series. So that means that inductor and capacitor both are in series. So instead of y1, I get an inductor in series with a capacitor. Inductor value is 32 by 3 and capacitor value is 3 by 32 farads. Inductor value is 32 by 3 henries, capacitor value is 3 by 32 farads. Similarly, y2. So instead of y2, so again y2 also we have written as 1 by z. So it means that these two are in series since impedances are being added. So L value is 32 by 5, capacitor value is 5 by 288. So instead of Y2 also we get series combination of L and C. Inductor value is 32 by 3 henries and capacitor value is 5 by 288 farads. So this is the network obtained after synthesizing the given impedance LC function using Foster second form. The third method is Core first form. So we know that we should write both the numerator and denominator in descending powers of S. So Z of S is equal to, numerator is 4S power 4 plus 40S square plus 3. If you multiply, you get this, and the denominator if I multiply, you will get S cube plus 4S. So now we apply continued fraction to this expression. So S cube plus 4S and 4S power 4 plus 40S square plus 36. So here also since I have S cube, but I want 4S power 4. So multiply by 4S. So you will get 4S power 4 plus 16S square. First term. So always multiply with the term such that in every step the first term gets cancelled. So you get 24S square plus 36. Since remainder is positive, the same term is carry forwarded here. S cube plus 4S. So here I have 24S square. I want S cube here. So in eliminating 24, and instead of S square I want S cube. So here I write S. So I multiply S by 24. So this becomes S cube and this becomes 3 by 2S. So here I will get 5 by 2S. So the remainder is positive, 24S square plus 36. So here anyhow I have to multiply by S since I want S square here. So 5 by 2, if I multiply by 2 by 5, and instead of 5 by 2 I want 24, so it is into 24. So we will get 24S square. Remaining with 36. I will continue here. So 36 here, 5 by 2S. So here I have 36, so I'll first eliminate that 36 and I want 5S by 2 in place of 36. So that term will get cancelled and the remainder is 0. Since this is applied in impedance, this is Z1, this is Y1, this is Z2 and this is Y2. So Z1, it is in the form of LS. So L1 value is 4 henries. So Y1, it is in the form of CS. So C value right here. So Y1 is in the form of CS. So on that C1 value is 1 by 24 farads. So Z2, if I multiply that, it is 48 by 5 S. So it is in the form of L2S, which implies L2 is 48 by 5 Henry. In the last term y2, it is, if I multiply, I'll get 5 by 72s. So it is in the form of C2s. So which is C2 value is 5 by 72 farads. So the ladder network, the first term is inductor 4 Henry, the second term is a capacitor 1 by 24 farads, the third term is an inductor of value 48 by 5 Henries, and the last term is a capacitor is 5 by 72 farads. So this is the network obtained after we synthesize the given impedance function belonging to LC using core first form, and the last method is core second form. As we know, the difference is we have to arrange the numerator and denominator in descending powers of s in core first form and in ascending powers of s in core second form. So the given expression can be written as, so in ascending powers of s, the numerator becomes 36 plus 40s square plus 4s power 4. The denominator becomes 4s plus s cube. So applying continued fraction, 4s plus s cube, this is 36 plus 40s square plus 4s power 4. So here I have 4s, I want 36. First I'll remove that 4s and get 36 here. So this becomes 36 and this becomes okay, this anyhow is 9, so it is 9s square, and this is 31s square plus 4s power 4. So we'll positive, remainder is positive, so if we carried forward 4s plus s cube, so here I have 31s square, I have here 4, so I'll divide 31s and multiply by 4. Since here you have s square, I want only s, so I have divided one s, so it is 4 by 31s. So I will get here 4 plus becomes 16 by 31 s cube. So will get cancelled. So here if I subtract, I will get 15 by 31 s cube. Since it is positive, again let us take 31s square plus 4s power 4. So here again 15 by 31. So first we'll eliminate that 15 by 31 by writing 31 by 15, and instead of that I should get 31 here. Here I have s cube, here I have s square, so 1 s I have to divide. So you will get 31s square, get cancelled, 4s power 4. So 4s power 4, since it is positive, 15 by 31 s cube. So here I have 4, so to take out 1 by 4, so I, instead of 4 I want 15 by 31. Here I have s power 4, here I have s cube, so I'll divide by s, so which will give me remainder 0. So this is Z1, since we have done on impedance function. This is Y1, this is Z2, and this is Y2. So Z1, we have got 9 by S, which is in the form of 1 by C1S. So the first element is a capacitor of value 1 by 9 farads. So Y1 is nothing but 4 by 31S. So 4 by 31S, it is in the form of 1 by Ls, since it is admittance. So L1 value is 31 by 4 henries. Similarly, Z2 is 31 into 31, that is 961. So 961 by 15S, it is in the form of 1 by C2S. So C2 value is 15 by 961 farads. And the last term, Y2, is that becomes 15 by 124. So it is 15 by 124S, which is in the form of 1 by L2S. So here inductor value is 124 by 15 henries. So we obtain all the terms. So the ladder network, the first term is a capacitor. So first term is a capacitor of value 1 by 9 farads. The second term is an inductor of 31 by 4 henries. The third term is a capacitor of 15 by 961 farads. 15 by 961 farads. And the last term is an inductor of value 124 by 15 Henry. 124 by 15 Henry. So this is the network obtained after we synthesize the given LC impedance function using core second form. So this was the procedure how we can synthesize a given LC impedance function using 4 canonical forms. So this was the procedure how to synthesize a given LC impedance function using 4 canonical forms. So this brings the end of my lecture on network synthesis. Thank you.